All right, this is going to be 5A work, 5A work. So which graph best represents the greatest amount of work? We know that work is force times distance, and well, if we take a look at the graph, we know that area is base times height. This is something you should know. And we know that the area of a triangle is 1/2 base times height. Well, let's take a look at the graphs. Your base is your distance, right? My base is my distance, my height is my force. And guess what? Well, area, well, is distance times F. Well, what formula does that look like? That's work, right? Force times distance, force times distance. So my work is my area. Well, which gives you a greater area? A square right here or this triangle? For sure, there's a greater area on this square. Well, which gives you a greater area, this square right here, or this rectangle. Well, the square again is going to give you the greatest area. So B is the answer. You don't even have to do any math. You just have to look at the question. Solvable in less than 10 seconds. Number 2, you exert a horizontal force 20 newtons east, and again, you should always write your direction because what happens is that you guys just end up forgetting your direction. So your displacement is 5 meters, you travel distance of 5 meters, and your work done on the box was your total work done. Well, we know the formula for work is force times distance. So my force is 20 and my distance is 5, which I do get a work of 100 joules. So the choice answer is B. And so that's not 13, that's actually 3. I'm too lazy to erase that mark though. So the question says how much work is done by lifting a 0.1 kilogram hamburger, 0.1 kg hamburger, 0.3 meters, vertically upward at a constant velocity. Well, and we know that work is force times distance, but we don't really have a force here. Well, if we think about it, well, what's acting on this hamburger, right? What's acting on this hamburger? Well, there's a force of gravity acting on that hamburger, and there's a force lifting lifting the hamburger up, and we're gonna call that the applied force. We're gonna call that the applied force. And now I'm gonna skip the proof part, and I'm gonna just straight up tell you that Fg is equal to Fa, because that's the only thing you need to remember, right? You don't need to know why it is. If you want to know why it is, you can come talk to me, and I explain this in class as well. Or you can watch a video, my work video. But if you don't care about the proof, just know that Fg is Fa, okay? So if you're lifting something, then you can assume this to be true, okay? Only if the object is, if only if you're lifting something up, all right? Only if you're lifting something up. And so we know that Fg is mg, and so my mass is 0.1, and my g is acceleration due to gravity, just a positive version of acceleration due to gravity. And so and we're around 9.8 to 10. So 10 times 0.1 is going to give you a force due to gravity of 1 Newton. And if Fg is 1, and if we know that Fg is Fa, then we know that Fa is 1 as well. Which means that, well, now we can solve for force, right? We can solve for work now. Because we have D and we have force, so, well, what's 1 times 0.3? Well, 1 times 0.3 is 0.3 joules. And so the answer is going to be C. All right, now let's move on to number 4. How much work is done? Right, work is question mark. We're required to lift a 10 Newton weight. So they already give you the weight. They say it's 10 newtons. Because again, Fg is weight. That's another name for it. Fg is weight. 10 Newton weight. And weight is measured in newtons. From 4 meters to 40 meters. So your distance that you're traveling in is 36 meters. Why? Because you're going from 4 meters to 40. The difference there is 36. And so, well, again, we know that we proved, well, you gotta trust me. I proved in class that Fg is Fa. But if you don't want to remember the proof and you don't want to understand why Fg is Fa, then just assume that, okay? Only if you're lifting something. So work is my force times distance, and we know Fg is Fa. So F for my force is 10, my distance is 36, 360 joules. That is my answer. And 360 joules, well, if you don't know how to do scientific notation, I need to put a dot over here. Dot after the first number. After you put a dot in the first number, count how many spaces from the beginning. And this is for if you don't know how to do scientific notation, this is the easy way. So I had to do 3.6, right? And since I have two decimal places here, well then my exponent is going to be a 2. All right, and so that's my answer. 5. This one relies on you knowing how to do vector independence. It says a constant 20 Newton force. Angle is 25 degrees. How much work does he do? Horizontal distance of 4 meters. Now, from a first glance, we know that, well, work is force times distance. But we want the work done to move it the horizontal distance. We don't want the total distance. We want the horizontal distance. So we want the horizontal force. Well, how do we get the horizontal force? Well, there are two ways to do it. There's like you can just use your knowledge from math, right? And so if this is 20 newtons and this is 25, and we want the horizontal force here, which I'm going to call Fx, then we just use trig. Right? And since Fx is your adjacent, right? Fx is my adjacent, and 20 is my hypotenuse, and my angle is 25 degrees. Well, we have adjacent hypotenuse. Well, the only thing we can use is this, right? Because it has adjacent and hypotenuse. My angle is 25. My adjacent is Fx. My hypotenuse is 20. So move 20 to the other side. 20 cosine 25 is Fx. And Fx is going to give you, let me do 20 cosine 25. So 20 cosine. Hold on. 20. 25. It's really difficult when you don't have a an actual calculator. 20. Hold on, I'm just gonna use Google. Give me a second. 20 cosine 25 degrees. It's gonna give you 18.1. God, that took a long time. 18.1 newtons. So that's your force in the horizontal direction. Well, now we have our force in the horizontal direction, we can solve for work. Alright, so my force is 18.1. D is 4, and I'm gonna get around 72. Actually, that's joules. So the answer is C. Answer is C. Now, let's say you want to do, let's say you don't remember any trig at all, right? On your reference table, you should see these two formulas. You should see this formula right here. All right, and you should see this one as well. What this is saying is that my x vector, right, and this is a, your hypotenuse is a, and your horizontal is ax, and your vertical is ay. It's saying that, well, ax, right, ax is a cosine theta, and ay is a sine theta. This is on your reference table. If you don't want to remember your trig at all, just figure it out. Just use the reference table, and their formulas are right there. No, no memory necessary. Just, I mean, the only thing you need to memorize is where to find it on your reference table. A student applies a 20 Newton force, 20 Newton. Moving at a constant speed, 4 meters per second, across a rough floor. How much work is done? And time is 6 seconds. Well, we know that work is force times distance, but we don't have distance. But there's an easy way to get distance, right? There's an easy way to get distance, and distance is, hold on. Distance. Well, on your reference table, V bar is equal to D over T, right? And if we solve for D and we move T to the other side because we're multiplying times time, we get V bar T is equal to D. Well, can we solve for D? Yeah, because V is 4, T is 6. And why can I take V bar as 4? Because the average velocity of a constant speed is going to be the same number. All right, my speed is 4 meters per second at 1 second. My speed 5 seconds later is also still 4 meters per second. So what's the average speed of these two numbers? Well, 4 plus 4 divided by 2 is going to give you 4. And so that's why I can just take my average velocity as that number. And so my distance is going to be 24 meters. Okay, so now we have our distance and we have our 4. So 20 times 24 is going to give me 480 joules. All right, so that's the work.